to our final talk of the day by the illustrious Teddy Seidenfeld, who I think it's fair to say has contributed as much to IP as any other philosopher in history. If there's a kind of topic in IP that you're writing about, there's a good chance that Teddy's already written about it. And so I'm very excited to hear him tell us a bit about the strategic aspects of forecasting with strictly proper scoring rules. Take it away, Teddy.
Thank you very much, Jason. Can people hear me and see the slides? Good.
Yes.
Thank you for your patience. This is the end of a long day, a lot of very interesting talks. I'll try and head off in a somewhat different direction because the conference is about epistemic utility and imprecise probabilities. And I want to focus on utility theory and point to some issues that I'm confident are inherited by any attempts to do IP for epistemic utility. Let me tell you how I'd like to spend the 45 minutes with you. So working backwards, just so that you know where you're going, I'm going to argue that there are issues that are properly categorized as strategic aspects of forecasting with a proper scoring rule. And that sentence sounds like it's nonsense because the usual advertising for proper scoring rules is that because it's a mechanism designed for eliciting means of distributions, takes away all the concerns about strategic aspects. I think that's not correct. So I'll be bold and say, I think the economic literature has gotten caught up in a judgment which is more subtle than they think. And I believe this issue is inherited by epistemic utility, which tries to use scoring rules as indices of cognitive goals of accuracy. So that's where we're going. And so to soften you up to get there, I want to just remind you about strategic aspects of games like Di Finetti's betting game or gambling game, and then remind you why it's thought that when he switches to forecasting game with Breyer score, those issues go away. That's part two. Part three will then point to where I think the oversight is, what's generating the oversight, and then we'll come back to what I take to be the controversial. Well, I don't think it's controversial, but I think it's at least surprising that there's nonetheless serious strategic aspects in using a proper scoring rule for forecasting, and that will be whether the scoring rule is thought to represent epistemic or economic goals. So that's where we're going. I'm happy to take interruptions for clarification along the way, and just speak up because I probably won't watch the chat well enough.
Yeah.
Or if someone's doing it in chat, Jason, if you want to watch it and just alert me that someone has a question, preferably clarification. Yes?
Yes.
We'll alert you. Yep.
Fine, thank you. Okay, so we're going to be working with a criterion of coherence, which is dominance. This is what sits behind Di Finetti's theory and all its variations. And here we're thinking of options or acts or gambles, however you want to describe them. There'll be the rows in these matrices as functions from states to outcomes. So here I've got two options, two rows, A1, A2, with the outcomes doubly indexed by the row and column. And we're dealing with in the simplest case, a finite partition, and the decision problem is amongst options that can be thought as functions from states to outcomes. And suppose that the agent is at least able to compare options within a state. This will be an issue later about cross-state comparisons, but down a column, suppose there's no issue, and suppose for the case at hand, suppose that for each column, the outcome in the lower row is strictly preferred to the outcome in the upper row. Then in that case, because we've got a finite partition, we'll say that A2 simply dominates A1, and the coherence criterion will be that whenever A2 dominates A1, say in a finite partition like this, then A1 is inadmissible in any choice problem where A2 is feasible. That is, if A1 and A2 are both in the menu, then A1 has got to be inadmissible because of A2's presence. There may be things better than A2 to do, but as long as A2 is present, A1 is inadmissible because of the dominance. That's the basic idea. Now, Diffinetti developed two games based on dominance. The more familiar one, which is the one he worked on in the 30s, started in the late 20s, I believe, actually, is the one which specializes to betting, but I'll try and point to the general case because we'll be needing this also for the forecast problem. He doesn't restrict himself to finite partitions. So if you want, we can think about some countably infinite partitions. But what we are looking at as our options are random variables. These are the xi. Do you see my cursor when I move it over here? Good.
Yes.
So we have a collection of these random variables, which are functions from the partition of the states to real numbers. So now we've simplified the outcomes so that each outcome is a real number. And to keep out of St. Petersburg paradox problems, if we're really going to deal with infinite partitions, we're going to deal with bounded random variables so that the infimum of these, for each random variable, the infimum over all the states is some number that's bigger than minus infinity, and the supremum is less than positive infinity. So we're dealing with bounded random variables. And that's only to keep away problems of St. Petersburg. Nothing I'm going to say about today really rests on that. The problems arise quite seriously within the bounded random variables. So to go back to my table, now the rows are the options, they're random variables, they're real valued outcomes. Their real values under the states are the outcomes, and we're going to be treating these quantities as commodities in Diffinetti's game, where there's buying and selling going on. Buying and selling of the random variables. So coherence one, Diffinetti's first game, the provision game. Now I'm gonna, because I want to highlight strategic play, I'm going to emphasize some game theoretic aspects of this provision game. I don't think it's exactly the way Diffinetti presents it, but I don't think it distorts what he's after. It just allows me to emphasize strategic aspects. And so there are two players in the game. There's a bookie, or you can think of as a merchant, and then there's a gambler or a customer. And the bookie is going to be obliged for each of the random variables in this collection chi to announce a fair price, a provision called P of X, or denoted P of X, which is a price that is two-sided in the sense that the bookie can be compelled either to buy or to sell at this price. Now, of course, in stores, they don't give you those two-sided prices. This is an idealization. One way of generalizing this to IP is to replace the single fair price with two prices, an upper and a lower, where the lower price is the highest buying price that the bookie wants, and the upper is the minimum selling price. That would be a bit more realistic. There's nothing in what I'm going to do here that is blocking that generalizations, but I'm going to keep to the original Diffinetti game. So the bookie plays first and is obliged to announce these two-sided prices, prices at which the bookie compelled either to buy or to sell the random variable. And the gambler or the customer plays second, sees the bookie's menu of prices for random variables, and then can make finitely many contracts with the bookie at the bookie's price. Let's get into that a little bit more detail. So again, the bookie first announces a price, say P of X, for buying and selling the random variable X. Again, X is well defined by that row, which gives you its real value in states. The gambler gets to choose terms. Here I've color-coded things, blue for bookie, green for gambler. So the bookie is playing first and announcing a price for the random variable X. The gambler plays second after all the prices are offered, and then chooses to make contracts by fixing these terms alpha sub x. If alpha sub x is 0, that's basically a pass, and there's no contract on the random variable x. But the gambler is allowed to fix finitely many non-zero alpha x. And the consequence of the gambler fixing a term alpha x that's non-zero is to produce a contract that the bookie is obliged to accept, in which the payoff to the bookie is this quantity. So let's look at this for two cases, alpha positive and alpha negative. Let's suppose alpha sub x is 1. Suppose the customer, the gambler, has chosen alpha sub x as 1. Then what the gambler is compelling the bookie to do is to spend the quantity px to buy from the customer a unit of x at the price p of x, and then the customer is promised to turn back to the gambler the value of the random variable in whatever state obtains. So in this case, the customer is receiving from the gambler a quantity p of x, and is returning to the gambler, is returning to the bookie the quantity of the realized value of x. And this then represents the outcome to the bookie opposite to the gambler. Again, if alpha is positive, the gambler is making the bookie buy the commodity at the announced price. If alpha is negative, then all the signs are reversed, and then the customer is paying to the bookie the price p of x and will receive from the bookie the realized value of the random variable. Any questions? Anyone questions about the contracts? These are supposed to be reasonably realistic ideas on a contract. So that's the outcome to the bookie when the random variable x is realized in state omega, with the price p of x that's been announced, and with the customer already having decided whether to buy or sell, and what quantity, the magnitude of alpha, tells you how many units. Could be fractional units. I want to buy 1.5 units of x, and so on. So the bookie's net outcome in this game is just the sum of all the contracts. Each contract gets resolved, you sum them up, and that gives you the outcome in state omega. And now we get coherence 1, the generalized version of the book argument. The bookie's provisions, those prices, are called coherent 1, provided that there's no strategy that the gambler has that can force a uniform sure loss for the bookie. That is, the gambler can't find finitely many terms such that for some positive epsilon, the net outcome to the bookie is negative, at least minus epsilon. And in terms of dominance, if you see the effect of the contracts, after all, the sum of those contracts is just another random variable. So we have on this row the net effect of the contracts, and here's the net effect in state omega 1 and state omega 2 and state omega n, and so on. And the alternative that's being compared is abstaining, which is status quo. And the question is, has the bookie allowed the gambler to create contracts where abstaining dominates the net outcome uniformly? If so, then the bookie is incoherent, is exposed to at least a sure loss of epsilon. If not, then said to be coherent. That's Diffinetti's game, the provision game, and then the famous theorem. A set of provisions is a coherent set in the sense, if and only if there's some probability such that the prices are the expected values of the random variables for that probability. So there's got to be at least one probability such that the announced prices match the expected value of those random variables, that the prices are the mean of the distribution of the random variables. And then a special case, which is nice, we can do most of our work with special cases, is when we're looking only at indicator functions for events. That is, we look only at random variables that take either the value 1 or 0, the one indicating the set of states that make up the event in question, A, 0, the complement. And then if we're only pricing these kinds of variables, then the expected value by the theorem, if they're coherent, is going to be the p probability of A. Of course, we have P of A times 1 plus 1 minus P of A times 0 as the required price, that's P of A. P of A times 1 plus 1 minus P of A times 0 is P of A. So if we're being coherent, we have to be announcing the probabilities. And that was DiFinetti's basic theory of personal probability. It was pricing random variables, and in particular, if you're pricing indicator functions, then your prices are your personal probabilities for the events. Let me skip example of incoherence. I think we can come back to those if you're interested. I'm concerned to remind you about what is well known, that this game allows the bookie to engage in strategic pricing. What do I mean by strategic pricing? Well, announcing prices which, though coherent, are not the bookie's degrees of belief or credences. And I'll give you some examples of this. The common theme in all these is that once the bookie knows who the gambler is, or if the bookie knows who the gambler is, who the customer is, then the bookie can customize or will want to customize the prices to what is known about the gambler's attitude towards these random variables. So for example, suppose the bookie has a straightforward, that is honest, fair price of little p in the event A, but models the gambler as having a higher fair price. That is, the bookie might say, oh, the gambler is another coherent agent who has prices, and I know enough to know that the customer thinks more highly of this random variable than I do, places it more highly. At CMU, this is a model of my interaction with Richard Shyness, who is in my views, overly optimistic on the Pittsburgh Pirates baseball team. And every time I go to bet with him, I say, well, if my odds are 50-50, his are at least 0.6 in favor of the Pirates. So I don't need to say 50-50. I can choose a price between ours, raise the price, and I know he's going to be happy to buy at what for me is an inflated price, because his value is higher still. Why should I announce my honest opinion when I can announce a higher price? And that will dominate, because if he buys, as I expect he will, at the higher price, I will pay less to get more in the same gamble. I will put up less of the stake for a chance of winning more of the stake. So the bookie does better by strategic pricing, and strategic pricing in that sense dominates straightforward pricing if the bookie's model of the gambler is accurate. There's always that concern that the bookie might be mistaken about the gambler's values, the customer's values. But if not, I mean, it's the same sort of thing you see in strategic voting. I will customize my vote to what I think the others are voting. If I'm right, I'm doing better. Of course, if I'm wrong, I may be screwing myself. Let me give you another example, which I like. This is quite dramatic. I use it all the time when I teach, as author will witness when we get to the example. You've seen me do this. So the bookie now has to price an indicator variable, an event, but believes the gambler already knows which of the event or the complement obtains. Let me give you an example. I'll switch to Miriam because authors already suffered through the embarrassment of having to be the subject in this. Suppose I'm asked to bet on the odd or even state of Miriam's mother's birthday with regard to a month. That is, was she born on an odd day of a month or an even day of a month? And I know that Miriam's going to be the gambler. I have to post these fair odds now. Well, my honest opinion might be random birth over the year, in which case about 51% of the days are odd and about 49% are even. And so if I was straightforward pricing, I would say 0.51, 0.49. 0.51 is my price for odd, 0.49 my price for even. But if I'm announcing that price for odd, 0.51, I know that Miriam knows the answer to this, and she will put me on the losing side of the bet by choosing the sign of alpha. That's at her discretion. So if A obtains, she'll make me sell her the bet. And if a complement obtains, she'll make me buy the bet. In either case, she can raise the stake to whatever my budget is for betting and take away all my money. Now, we have to be careful here. I will lose for sure, but I'm not a sure loser in Diffinetti's sense, because the strategy that she has depends on whether her mother's birthday is on an odd day or an even day. There's no one strategy that works in all states, but that's no recourse for me, because if I'm going to bet against Miriam in this particular case, the fact that I'm not a sure loser, but losing my money for sure still results in my losing my money for sure. But there's something better I can do. I can play coherently and at least weakly dominate my straightforward play. I will play boldly. If P of A is 1, if I think that its odd is greater than a half, I'll announce her a price of 1 on odd. If I think P of A is less than a half, I'll announce a price of 0 on odd. And if it's a half, I'll say either way. Why is this superior? Because with probability at least a half, I'm not losing anything. Because if I put all the odds, all extreme odds on the correct state, she can't win anything, I won't lose anything. It's only if I get it wrong, then I lose everything I've got to bet with, but I was going to lose everything I've got to bet with anyway if I don't do this. So the strategic action here in playing against an expert is to play boldly, extremely, go to extreme odds. And this is not so surprising when you look at the theory of optimal play in unfavorable games. There are quite a few general results about if you're playing in an unfavorable game where the odds are against you, so to speak, bold play is optimal. There are lots of results about this. This is a simple example where bold play is optimal because clearly this is an unfavorable game to me if I've really got to bet against Miriam on something she knows the outcome. She has insider information. I can't get around that. Any questions about this example? Pretty clear, pretty dramatic. So here's a Kipling just shows so story. Diffinetti was a radical operationalist. That's not just so. And he was concerned about these issues related to strategic pricing because the strategic prices that were announced are not the bookie's subjective probabilities. That is, this is not a very good operational procedure for identifying the theory of personal probability. If the bookie's announcing strategic prices, what the bookie announces depends on who the gambler is, who the bookie thinks the gambler is. This is undermining the operationalism that Diffinetti wanted. But even without being a radical operationalist, at least the strategic play corrupts the elicitation of the bookie's subjective expectations. If I'm trying to figure out what the bookie's subjective expectations are, these contexts for strategic play make it very difficult for me to reconstruct what the bookie's honest opinion is. For in example 3, betting against Miriam about the odd or even day of her mother's birthday will only tell me whether the probability is at least a half or no more than a half when I see which extreme she goes to. I won't be able to get any more information than that. Okay, part 2. So here's the part of the Kipling just so story. Diffinetti, starting about 1960, started to downplay the provision game as the basis for his theory of personal probability and switched over to a different game, a forecasting game, which was designed to mitigate these concerns about strategic pricing. In game 2, there's only one player. It's the forecaster. And the forecaster looks at the same random variables and it has to announce a real valued forecast for each one of them, subject to squared error loss, Breyer score. So in state omega, the forecaster is penalized by the Breyer score, the square of the difference between the forecast and the realized value. And then the forecaster's net score in state omega from all the forecasts is just sum of the individual losses. So again, we're doing sum of individual losses. Coherence 2, the second version of dominance Diffinetti used. The forecaster's forecasts are coherent in the second sense, provided that you can't find finitely many variables that are being forecast, and a rival set, F primes, those primes there, rival set of forecasts, such that the rival forecasts in every state give you a uniformly better score, smaller loss. That is, it can't be that the negative utility is worse uniformly with the real forecasts rather than the rival forecast. In the sense that the forecaster, if announcing F when such an F prime exists, could dominate her his own forecast by switching to the rival outcomes O prime. What's important here to realize is that in this case, though it's still a principle of dominance, there's no simple alternative that's always doing the domination. It's the claim that for the forecasts that came from F, I can find a rival forecast F prime if the forecast F were incoherent, such that the F primes dominate in score, not that there's some simple alternative like abstaining, which always wins. And this is going to be important for what's coming later. So Diffinetti's theorem circa 74 is that a set of provisions in the pricing game are coherent if and only if the same forecasts are coherent, if and only if there's some finitely additive, some probability where the forecasts or the prices are the mean of that distribution. So we've just added the pink F values and set them equal. And Diffinetti's contribution here was to show that if you violate this condition, then these forecasts are not coherent to their dominators with Breyer's score. So I'm going to skip. This is just illustration of Diffinetti's argument. Now you can say, why was Diffinetti interested in coherence 2? He already had the domination principle for coherence 1. It was that he realized that Breyer's score, as advertised by Breyer in 1950, had exactly the feature he was looking for mitigating the strategic forecasting. So this is what Breyer pointed out, which actually is a consequence of the old Gauss result about means minimizing mean square error, goes back long, long ways. So a subjective expected utility forecaster, a forecaster who has subjective expected utility model, whose forecasts are scored by a finite sum of squared error losses in utility, uniquely maximizes expected utility by announcing the expected value for each variable as the forecast. That's uniquely the best answer. And so Breyer's score is in that sense a strictly proper score. The expected value of the indicator, remember, is the probability of that indicator. So it looks like if I'm an expected utility maximizer, not only am I going to be coherent with my forecasts, but I'm going to reveal directly to you my honest opinions, because the means of my opinion of my distribution are uniquely the expected utility maximizers. And this generalizes later to all strictly proper scoring rules, but we can stick with Breyer's score. Everything I want to say is exemplified by Breyer's score. So this was thought to be the resolution of the concern about strategic pricing and subjective probability, rather than using the provision game, switch to Breyer's score and forecasting. And the reason being that the forecasting game with a strictly proper scoring rule preserves the central theme that coherent play requires playing in accord with the theory of subjective expectations, and sidesteps the concern about strategic play because the agent will always be playing straightforwardly, because the strictly proper scoring rule is meant to elicit exactly the mean. Only the mean will be revealed. Okay, we're down now out of the familiar stuff. I've gone, what, about, how long have I gone? I've gone About half hour already?
Half hour, yeah.
Okay, yeah, so I've got 15 minutes to illustrate what's coming next. So now comes the part where I think there's a problem with strategic aspects of forecasting. But to get you to see it, I have to dig a little deeper into some of the soft underbelly of subjective expected utility representations. Suppose we have an agent whose preferences over acts, again, I'm back to generalized outcomes, is represented by some probability state-dependent utility pair where the probability is on the states. I take expectations, but of a utility function where the utility of the outcomes are allowed to be indexed by the state. So the outcome 011 might be the same as the outcome 013. In both cases, you get a certain kind of slice of pizza, but the utility of 011 in state 1 is not the same as the utility of 013 in state 3. That's allowed to be the case. Maybe you've got an upset stomach in state 3, and pizza that is fine in state 1 is not so good in state 3, and something else would be better. Okay, and suppose that this representation is adequate for picking up the agent's preferences over acts. Notice this J allows the utility to be subject to the state, doesn't require it. Okay, but so this is a bit more general representation. It's allowing a state-dependent utility to be used in the representation of subjective experience. Now comes the unhappy news. Let Q be any probability on the same states that agrees with P on the null events. Again, I'm using colors, but they're not related to the provision game. They're just two colors I'm using. So I had a representation. I'm supposing that P and the UJs are adequate for representing expected utility, state-dependent utility. And now I'm going to show you there are lots of rivals. Let's suppose Q is any distribution which is mutually absolutely continuous with P. They agree on where their zeros are on this state. Wherever P assigns 0, Q will, but and wherever Q assigns 0, P will, but other than that, Q and P can be very far apart. P can assign probability very high to some events that Q assigns very low probability to. Let Vj be a different state-dependent utility defined by this little product, which looks at the ratio of P to Q state by state. If you want to know where this is coming from, I'm using the Radon-Nikodym theorem and looking at the density function that would connect the P distribution with the Q distribution, but I'm absorbing the density into the utility function. So now we get the following trivial piece of mathematics. The pair PUJ represents this preference, namely expected utility agrees with preference if and only if QVJ does. Just look and see the triviality of this. Q times VJ is Q times P over Q times UJ. Well, the Q's cancel and I'm back to P and UJ, which we agreed by supposition was adequate. So this is a piece of bad news in the sense that coherent preferences underdetermine the separation of credences and values when state-dependent utilities are entertained. Now I'm going to show you how to make give us a little heartburn. So consider two currencies. Since we're in Bristol, I want currencies that are not local. So we have US dollars in red and euros, EU euros in blue. We can bring the pounds in if we need to. And suppose our agent who's going to be doing the forecasting believes there's a state-dependent exchange rate. Now, it might be that these events are political events, like the outcome of an election in Germany. And these are the agent's beliefs about what those consequences for the exchange rate would be between the two currencies. But I'll take a moment that the agent is operating with firm beliefs that in state omega 1, a dollar will be worth 2/3 of a euro. In state 2, $1 will be €1, and in state 3, $1 will be worth €2. Let X, Y, Z represent the gamble that rewards, an act that rewards X in state omega 1, Y in state omega 2, Z in state omega 3. These could be X, Y, and Z in general could be bundles of dollars and euros. So many dollars and so many euros. Could be a shopping cart that way. Suppose the agent is indifferent amongst these $3 gambles. The gamble that gives you $1 in state 1, 0, and 0 in states 2 and 3. $0 in state 1, 1 in state 2, and 0 in state 3, and 0, 0, 0, 1 in state 3. Indifferent amongst these. These are the indicator functions for the 3 states using dollars as the unit for monetizing those random variables. In the provision game, if I went back to the provision game, these indifferences would compel unique prices of a third, a third, a third on the 3 states. It's not hard to see. That is, if I go and play the provision game in dollars and the agent has these indifferences, there's only one set of prices that work because the agent is saying state 1 is equally desirable as getting my price of $1 in state 1 is in state 2 is in state 3. That gives me a third, a third, a third in dollars. Now, those $3 gambles are by the rate of exchange, each one respectively indifferent to so getting $1 in state 1 is equivalent to getting 2/3 of a euro in state 1 and 0 and 0. So I've just done the conversion according to the agent's state dependent exchange rate. So now the agent is saying in euros, I'm indifferent between this gamble and this gamble and this gamble, because each of these is the state dependent equivalent of the gambles that I gave in red before. The indifference amongst these 3, if we now go back and play the provision game in euros, requires a half, a third, a sixth. Those are the only prices that match this indifference if I now start to play the provision game in euros. So basically, we've got 2 pairs. We've got a probability in dollars and a utility which treats dollars as state independent, but not euros. That's the one that will be a third, a third, a third, and dollars are state independent in utility. A dollar is a dollar is a dollar. Or and then euros are state dependent because of the exchange rate. Or I can use this distribution, a half, a third, a sixth, treating euros as state independent in value, but not dollars. These are 2 different state dependent utilities, but they're related exactly by that little trivial basic result. This pair and this pair rank all equivalent lotteries. Lotteries, when you convert them according to what the agent believes are the appropriate conversion rates, exactly the same way. This is one state dependent personal probability state dependent utility representation for preferences. This is the same ranking of all gambles when I convert to euros. Everyone understand? And there's no way of looking at the agent's preferences and saying this is the right one, this is the wrong one. They're indistinguishable in terms of what they suggest by way of preference, and preference is what we're going to see from the agent's choice of decisions. Okay, I've set things up so that, in fact, the marginal exchange rate between these 2 currencies is 1-to-1. And going through one of these exercises is worth doing, because this gets to be a little mind-bending, even though we're dealing with rather trivial mathematics. $1 is getting $1 in each state. Getting €1 is getting €1 in each state. The claim is the agent is indifferent between these. You want to see why? Write the €1 gamble in dollars. €1 in each state translates out as 150 in state 1, $1 in state 2, and 50 cents in state 3. What's the expected value of this gamble? It's in dollars. We use the 1/3, 1/3, 1/3. So it's 1/3 times 150 and so on. That's $1. So the €1, when I convert to dollars, is equivalent, has an expected value of $1, which is then $1 is equivalent to $1, $1, $1. You can go back the other way, you get the same answer, of course. What this means is that if a gamble has an expectation when converted to dollars of K dollars, then when it's converted to euros, and we use the appropriate probability for dealing with state independent euros, it has an expected value of K euros. The exchange rate is 1-to-1, even though there's state dependence in the exchange rate. This will allow me to make some judgments about how the agent wants to forecast. So in the provision game, announcing P prices in dollars or P prices in euros doesn't matter, because all fair contracts are indifferent to each other. The agent is always announcing a fair price that makes the gamble, if it's straightforward pricing, all fair contracts are indifferent to each other because the agent is announcing prices that have an expected value of 0, and 0 is 0 for dollars and euros. In the provision game, that's not true. We're making some progress. Let me, I've got a little bit, am I out of time?
No, you still have a few more minutes.
And feel free to take.
It'll just reduce Q&A.
It'll reduce Q&A, but it's the central point, so take some extra minutes.
I know I was going a little bit more slowly than I should have, but as I say, this is surprising, so I want to make sure that I'm not jumping over any steps. So suppose the agent is asked to forecast each of the 3 states, 3 forecasts, one for state 1, one for state 2, one for state 3, and let's check and see what's going on. Monetized in dollars, the expected Breyer score loss for each forecast is 2/9. Why? Because it's a 1/3 probability for each state. You announce that by the proper scoring feature of Breyer score. And so with probability 2/3, the event fails. And so it's 2/3 0 times 1/3 squared plus 1/3, 1 minus 1/3 squared. This is all in dollars and expectations with regard to dollars. So the expected loss associated with the 3 forecasts in dollars is a loss of 2/9 of a dollar. That's my expected loss if I'm forecasting the 3 events in dollars. If I monetize in euros instead, and so we play the game in euros, then I will announce a half as my expected, as my forecast for state 1, because that's the expectation when I'm playing the euro game. And so it will be a half times, with probability a half, the omega 1 fails. And so it's a half 0 minus a half squared, a half that occurs. 1, that's the outcome of the random variable, the indicator function, 1 minus a half squared. The expected loss is the expected loss is 1/4 of a euro, which is greater than the expected loss if I were using my dollar forecasts. Let me go through and finish these up. In state 2, the exchange rate was 1/1. So as you would anticipate, the expected loss is the same in both. And in the third state, where the dollar forecast is 1/3 and the euro forecast is 1/6, the expected loss is less in euros than it is in dollars. What does this mean? The agent strictly prefers forecasting omega 1 in dollars rather than in euros because there was a 1/1 exchange rate. This is the expected loss before I've learned anything for my forecast. I'm minimizing that by saying 1/3 in dollars or a half in euros, and I expect a smaller loss if I forecast in dollars. So for state 1, I want to forecast in dollars. For state 2, it doesn't matter because the expected loss is the same. And for state 3, I want to forecast in euros. So my forecast numbers, not paying attention to the units, would be 1/3, 1/3, 6, which seems incoherent because they're supposed to sum to 1. But they are coherent because the first one is monetized in dollars and the third one is monetized in euros. And the key here is that even if one of these is the agent's honest opinion, the agent will still play strategically and choose one currency for state 1 and a different currency for forecasting state 3, even if one of these distributions and one of them only is the agent's honest opinion. That's why this is strategic. You can't tell which is my honest opinion from seeing how I forecast. If we went through and looked at the case where the forecaster has to choose only one currency and is required to forecast all three in one currency, we still get an inequality. It comes out slightly better to forecast in euros than dollars. And that would be the case even if my honest opinion matched the 1/3, 1/3, 1/3 with dollar state independent utility. Even if that were the case, I would prefer strictly to do the forecasting game in euros. And you give you the probability a half, a third, a sixth. So we have, I think, an inevitability of strategic forecasting that results when we allow ourselves to monetize the random variables with different currency. Okay, last part, concluding thought. So we see that, and by the way, these strategic issues do not arise in the provision game, because in the provision game, if I'm playing straightforwardly, all forecasts, regardless, all prices, regardless the unit, yield gambles that have an expected value of 0. So I have no incentive of playing the provision game in dollars or in euros if I'm playing straightforwardly. Concluding thoughts. Forecasting events with a strictly proper scoring rule opens the door to strategic choice of currencies. Now, to get back to where the conference is. A popular theme in contemporary formal epistemology is to propose scoring rules as indices of epistemological goal accuracy, assess forecasts by their cognitive merits, where the magnitude of the loss is an index of inaccuracy of the forecast. And this is thought to offer a contrast with so-called pragmatic assessments of gambles, which deal with non-cognitive goals like wealth. I've been using monetary non-cognitive goals. What are the units of epistemic accuracy? That's what this talk is all about. What are the units of epistemic accuracy? Are there counterpart to rival currencies when fixing units of? Yes, because the basic proposition deals with all utilities and all probabilities. It doesn't matter whether it's a theorem about probability and utility. It doesn't matter whether the utility is epistemic or pragmatic. That little basic result applies. So the idea is if fx is the forecast for a random variable x, then in state omega, the forecast is penalized this amount. Suppose we agree on some state independent unit for indexing the cardinal utility. I found some epistemic unit of accuracy where it becomes state independent in that unit. The basic proposition allows me to switch to a rival set by choosing Q to be any mutually absolutely continuous probability. I go through the same thing and I reverse engineer the rival currency that goes with the rival proposition where the values are state independent in the rival currency. These are still measures of epistemic accuracy. So the problem is that one measure of epistemic accuracy where in my units it's state independent, like dollars with state independent works, if and only if this other one works, and now I find the units that make them state independent in V. I don't believe there's any way around that. This is what the slide is just going through that. So the concluding question, how does the interpretation of a loss function, the Breyer score, as quantifying epistemic goals in accuracy of forecast, avoid the problem of strategic choice of units of accuracy? Because remember, the example showed you that even if you knew which was my honest opinion about the three states, I would still want to forecast some in one currency and some in the other. The same thing happens if the currency is called an epistemic measure of accuracy. I want to use one of these units for some and one of the others. I will strategically choose them if you allow me. And I believe the issue applies equally to IP decisions that generalize subjective expected utility. We can now go through and generalize all this to sets of probabilities and utilities. Life only gets worse. So I'm going to stop. I'm going to stop here and say, I've tried to raise some concerns about the utility side of this conference by pointing to what is thought to be a stronghold of the precise theory that we can minimize strategic pricing by scoring rules. And I'm saying that, whoops, scoring rules actually have their own family of strategic pricing issues, which I think are pretty nasty for trying to get out of this problem of strategic forecasting. I think it's going to be inherited in the epistemic utility framework. So I'll stop there and let others apply the balm that will take the heartburn away.
Wonderful. Thank you, Teddy. Well, as usual, pop a Q in the chat. And we will start with Kevin and Miriam after Kevin.
Great, thanks so much. So, and thank you for sending the slides in advance, because I wouldn't have been able to wrap my head around this, I think, in order to be able to ask the question I want to ask about that. So what I think seems to me like what's happening here is that when we say that there is no sort of strategic pricing in the provision game, it seems like the reason that's true is that we're using these fair equivalents, right? So we're not using the marginal exchange rate of when we're looking at the gambles that we're saying, if you have a gamble expressed in dollars, like it's like, 1, 2, 3 or whatever, right? We don't translate that with the marginal exchange rate into euro. We use the sort of conditional exchange rate, the world dependent exchange rate.
Hold on, you're going a little fast for me here. So
Okay.
in the provision game, the outcomes depend, of course, on the realized value of the random variable, which we've monetized in one currency or in another. And associated with that currency, a price has been announced.
Right, but I guess what I'm saying, right? So when we're saying, like, what is the equivalent in euro of a wager in dollars? We don't use the marginal exchange rate. We use the conditional exchange rate. So, right, so if like the wager that is the constant dollar in euro is like, what is it?
Yes, that's right,
okay.
yes.
Okay.
That is, if I take a particular wager in dollars and ask me to reformulate it as its counterpart wager in euros, then I'm going to move over and give you euro values. And in the game we're playing there, we're treating euros as state independent in euro.
Good. Okay, so we're on the same page, right? So what I want to say, right, is when we're treating the Breyer score as a commodity that's payable in an actual currency, it's an actual loss function or an actual reward function, right? Then it is also just a gamble, right? You are also now just receiving different payments based on the different states of the world. And so if you want to have any hope of those eliciting the same preferences, you can't use a sort of flat currency conversion. You can't use the marginal exchange rate. So
no, I'm going to interrupt and say I'm not using a flat conversion rate state by state. The currency exchange rate had to do with the ex ante value of a forecast. How much is it worth before you've been paid anything? It's the same way when you go up to the window at the currency, you give them some dollars, they give you some euros. The amount they're giving you is ex ante to any of the realized states.
But the amount that you're getting penalized, so take the version of the Breyer score where like what's happening is, so you're writing down the forecast. You're not getting any reward, right? You just are getting a loss. And the idea is you just want to minimize that loss. So like it's, it's a game that kind of sucks to play. But this is the position you're in, and you just want to get like the lowest loss you can. So the loss that you're getting in each state of the world is being paid in the actual currency. And so the Breyer score in dollars, right, we're saying is the square of the truth value at the world minus your provision at the world, or your forecast at the world.
In dollars.
In dollars.
Yes.
And then when you were calculating the stuff in euro, you also said it was the truth value at the world minus your forecast squared, payable in euro.
Correct.
And that's what I think you can't do.
I'm not
right?
saying though, I'm not saying those are equivalent. That's the whole point. If they were equivalent, there would be no reason for strategic action. We're agreeing they're not equivalent.
Cool, right. But then, right, then the thought is, okay, so like obviously if you want to elicit the thing, right? So if you want to try to elicit the agent's like dollar credences, then the euro payments that you should offer for the Breyer score need to be not the flat.
Hold on. If you want to elicit the forecast in dollars, you pay in dollars.
But I'm saying you can also elicit it in euro. But then what you need to do.
How do you, not with Breyer score.
I think you can. I think you need to use the conditional exchange rate though.
But
right?
then you're not, Breyer score has a particular form. It's the value of the random variable minus the forecast squared. If you're not plugging that in, you're not using Breyer score.
But what I'm saying is in terms of, so we're now thinking of this as an actual commodity, right? That the agent values. So we're thinking about this as a utility. And if you want to pay someone in utility, and they think that there are different states of the world where this commodity has different values, then in order to pay them the same in utility, you are going to have to use those conditional exchange.
But why do you say I'm paying them the same in utility when we're doing Breyer score with forecast in dollars and forecast in euros? You're not getting the same payment.
Right. If you use the flat euro, that's true. But if your goal is, right, because like the goal of the Breyer score is to like want them to elicit, like you're trying to elicit their true preferences. Their true beliefs.
Okay,
And
I'm
like,
going to interrupt again. What Breyer score is eliciting is the mean of a distribution.
Yes. Okay. And in order,
do we agree that there's a different distribution for
dollar credences and euro credences? Yes, I agree. And I agree with like, it's really cool, like the way that you've outlined it in the slides. I liked it a lot. But the point is, if in euro payments, you want to elicit dollar credences, you're going to have to use a conversion, right? Because the utility is not the same. If you use the flat thing, then like, yes, right, it is obvious like why there will be strategic consideration.
No. May I table a suggestion?
Please.
The comments, I think that will be circulating will all touch on this point. So perhaps we will take additional questions in the queue and these issues will become illuminated as the Q&A goes on.
Yeah, good. We should move on. So, sorry, but thank you very much.
And I should say on behalf of the whole team, since we read the slides, our enthusiasm about the question is genuine excitement. I mean, we're getting heated because it's an exciting topic, but I hope you don't take it any other way.
I might have another comment later about something that I hadn't thought about until I read the slides, and like I'm really glad you made me think about. So, but yeah, but
okay,
thanks.
Good. We'll continue the enthusiasm with Miriam.
Yeah, I'm also heated up, though I did not have the privilege of getting to read the slides in advance. So I'm still kind of trying to piece this together. So this is really just maybe a request for you to go over a certain part of it more slowly. So I kind of followed what was happening with the euros and the dollars. And then at the end, it was like, well, this is how this applies to epistemic utility theory. And so that, I guess that's just the part that maybe, so what I was hoping you could do is kind of like walk me through sort of step by step, kind of how a deliberator trying to maximize expected accuracy is going to like run into this problem. So suppose I'm 0.8 in P, and what I care about is maximizing expected accuracy according to the Breyer score. What I care about is accuracy according to the Breyer score, and I want to maximize my expectation of it. And so I think to myself, okay, well, 0.8 maximizes expected accuracy according to the Breyer score relative to me. And then, so I'm going to like stick to 0.8. But then am I supposed to think, but wait a second, is it the Breyer score in euros or in dollars? And like, then maybe I'll get a different answer. Like,
yes, that's exactly that problem. But instead of talking about it euros and dollars, because that's supposedly contaminated with practical mundane matters like monetary currency, we now have this new realm of epistemic utility. And I'm saying the Radon-Nikodym theorem applies to all utilities. And so there will be multiple units of epistemic accuracy, that can be formulated, which have equivalent probability, that is, probability pairs match up with them in an equivalent way, in the sense that the P and the U pair will be equivalent to the Q and the V pair, and the U and the V will still be epistemic utility units. It's just that they will be related in exactly the same way that you were a bit more comfortable in, or it was a bit more transparent in seeing what was going on with dollars and euros.
So when, so maybe this is related to what Kevin was asking, but I guess I thought that like in decision theory, both like expected utility theory and epistemic, like in practical utility and epistemic utility, like we had this, like utile was a unit. So like when we're not talking about like pizza, we're talking about utility, then like we have our unit. We don't have like units of utility, like different varieties of utile units.
Let's agree that my preference amongst kinds of pizza is state dependent in utility, in the sense that I'm not always preferring a margarita to a pepperoni. In some states, I prefer it the other way around.
Okay.
So now if I want to talk about the desirability of a margarita pizza, which means getting a margarita pizza in every state, right?
Mm-hmm.
The question is, do I want to treat that as a state independent utility, where whatever the marginal value I assign is, it reproduces in every state? If I do that, then I won't be able to say the same thing about a pepperoni pizza at the same time, because in some states, the pepperoni pizza will be preferred to the margarita, and in some states it will be dispreferred. So it can't have a constant utility. On the other hand, I could decide I want my unit to be the pepperoni pizza, and then the margarita pizza is the one that has the state-dependent representation. And the point is, the traditional expected utility theory, or the games that Diffinetti plays, presumes that we are using units that are state-independent in value, which allows me to play the game with pepperoni pizzas, or to play the game with margarita pizzas, but I can't play it simultaneously with both.
So what's the analog of the state dependence? Because also, yeah, in the slides you were talking about like a political event. Like what's the analog of that in the purely epistemic realm?
Well, part of it is I'm not sure how to create units of epistemic utility. If you show me one, I'll show you. If you show me one, I'll show you what the rival pizzas look like.
Mm-hmm.
But I'm saying the mathematics that says if you've got one, you've got too many is quite robust, because that's this Radon-Nikodym theorem. And so I can play the same game with epistemic utility units as I was playing with familiar monetary currencies.
Okay, there's quite the queue. I'm actually next in the queue. I will try to make it quick. I'll start with the epistemic utility question, because I think it illuminates sort of what I think is going on in the forecasting game. If I'm an expected Breyer score minimizer, and you take the state dependent, any state dependent, if I have an equivalent state dependent utility representation where the probability in that pair, that pair is different from the P, then the transformed utility function won't be a strictly proper scoring rule. And when you maximize that thing, you will get back, you won't report, if you were kind of minimizing that thing, because it's not proper, you're not going to report your own credences. You're going to report the ones that you were that were in the pair that in the original Breyer pair.
I'm not quite sure what you're saying here. I'm saying when you switch to the distribution Q and you calculate this Vj sub j state-dependent utility, the Vj state-dependent utility will have its own units that are state-independent. And so
all I'm saying is this Vj is not a proper scoring rule. And so Q
is a
will report
utility.
P rather than Q.
No, Vj is
Prior score paid in VJ won't be.
Right.
Breyer score paid in the constant units of Vj will be proper scoring rule for eliciting the Q distribution.
It's yes.
It's exact. I mean,
but you're not both.
Look, could you say what you were saying about dollars and euros?
Sure. I mean, I think the basic, well, I mean, this is a question on my part. I really am, I'm not saying this as sure that I'm right about this, but my initial reaction was, in your example, if you are a dollar maximizer, if dollars are linear in utility, then you're not a euro maximizer. When you hand me a gamble in euros, what I'm going to do is use the conditional exchange rate to.
I'm going to interrupt you and say that the dollars independent in utility with the P distribution is decision theoretically indistinguishable from the euro independent utility with the Q distribution. All decisions are equally represented. If I maximize P U utility with dollars independent in I maximize Q euro distribution when I perform the appropriate exchange rate. That is the same. That was the underlying trivial point. So I don't understand what the first claim is that you made. If I'm maximizing probability with respect to dollars independent utility, I am also maximizing expected utility with euros independent utility, but with a different distribution.
You're maximizing using Q, you're maximizing euros using the conditional exchange rate, since you're maximizing utility.
That's exactly right.
But you're not maximizing flat euros. I mean, and so in the forecasting game, when you express it in flat euros.
In the Q distribution, I'm maximizing flat euros.
Okay. I don't say this out of frustration. I don't want to monopolize the rest of the Q&A, so we will continue this.
I'm not understanding. See, you can see I'm not understanding the claims about saying you're maximizing in one and not in the other. The whole point of this is to say you maximize simultaneously in both. It's just a question of which unit you choose as independent in state value.
I agree with that point. We'll move on in the queue. Katrin, then Seamus, then Harry.
I'm actually not sure if I'm really, I'm not sure this is right anymore. So I was wondering if there was like any kind of connection. I don't know if you know, it is like Ben Levenstein has something on like, if you've got like the Breyer score, but like you've got weights for different propositions and you, how important different propositions are can be state dependent, then there's also some kinds of problems that arise and stuff. And so I was thinking it was like a way of getting like state dependent, pretty epistemic feeling things that led to problems, and it somehow seemed related to this, and I wasn't sure if it was.
I don't know that work. I'm ignorant of that work. From the way you describe it, it sounds like it might be a way of understanding what is the counterpart to the exchange rates.
I'm not.
Like you. I mean, based on what you're telling me, I'm feeling like there's some kissing cousin relation here, but we have to look at it.
The epistemic state-dependent utility and scoring rules, and accuracy measure, whatever, these things cause problems. I think that's insofar as I saw a connection, and I was, yeah, it may be interesting, or maybe some people here know the two things better and will be able to comment. Yeah, cool. I'll send you a link.
Thank you.
He waved himself off, and so we'll move on to Harry. Yep.
Can I go ahead? All right. So Teddy, I think you've convinced me. You've sent me this problem or description of it some time ago, and it took some time to study it, and I accepted it. But that may be because I'm not as emotionally invested in the existence of or epistemic utility making sense. So I'm probably more easily convinced than the rest of the people here. Now, I was wondering about a mathematical question. So I was wondering why this works and what makes this problem tick. And so I had the suspicion that your argument doesn't work for coherence 1, because there you have a linear cost function in a sense, and it works for coherence 2 because there the propriety of this score makes it go away from linearity, so you get concavity, and I think that's what makes this work, right?
Yes, that's critical. That's critical to why you get this phenomena for forecasting with a Breyer score and any strictly proper scoring rule, because any strictly proper scoring rule, continuous knot is going to have that concavity to it, and that's what allows creating the strategic interest in changing currencies, as I'm calling it, independent of which that is, whether I repeat, what for me was the surprising lesson is that whether my personal probability is better expressed or really expressed with the dollar's independent in value or with the euro's independent in value, when it comes to these forecasts, I still want to use one currency for state 1 and a different currency for state 3, and you won't know which is my honest opinion, even though I'm being strategic. You can't tell whether I'm being straightforward in my forecast of state 1 and strategic in state 3, or the other way around. Can't do it.
Okay, thank you.
The conference ends in
That's like 2 or 3 minutes.
so we'll be heading out in just. Okay. We're keeping security here, so I guess we're going to wrap up now, and we will carry on this conversation in the margins over the next day. So let's thank Teddy for an absolutely fantastic.